I am really just thrilled to be here. It's great to be back on campus and have all the great memories that I had from UCLA, although it was sleepless because I did do the EMBA program. And I thought I would start with just a short personal story to give you some color of how the world of genomics has changed even since I graduated with my EMBA. And here's me with my family in 2005. It was the year I graduated, and it's a fantastic experience going through the EMBA program. Made a lot of lifelong friends and colleagues, and a great network of alum. And you see my children there on the right of your screen, or of the screen. And they were about 5 and 7 at the time. I was general manager of about a $400 million business, driving up here with no sleep, taking an exam the next morning that I had not studied for. But still, I missed those times, so, so it was a great experience overall. And you see in the picture below, now my family has grown. The kids have gotten bigger. We added another one. And my husband and I got a bit older. But my oldest is actually is at an Ivy League school back east, freezing his butt off, and my middle son, who is making the face there, is now an amazing young man, a junior in high school, and I'm hoping that he will consider UCLA, where you can get that Ivy League education in the sunshine without the attitude. So. I think I heard Dean Olian say that once. So, and I want to give you a snapshot of the revolution that's happening in genomics. And we've had a lot of great perspective on what's going on in healthcare. And I'd like to give my own perspective of, I think there's going to be a lot of innovation that is required for us to bring down the cost of healthcare, to make it more personalized, and to really make an impact on everyone's life. And I feel the field of genomics has a lot to offer. I think it's going to impact all of your lives. I think it's going to impact the lives of your children, the lives of humanity. But there is a ton of work to be done. We're just at the beginning, scratching the surface, and we're going to need a lot of good people. We're going to need a lot of Bruins to make it happen. So I joined Illumina, as you heard, about 5 years ago, and the company has been growing on a very steep vector. We started as a startup in 2000. We incorporated, our current current CEO just took over last year, and prior to that, Jay Flatley was our CEO since the beginning of the company. The employee base has more than doubled since I joined, so just in 5 years. And we have 20 global offices. We've won a number of awards, business awards for our growth, and the award as a leader in R&D at the company. I'm very proud of the award we won in terms of the MIT Technology Review. We won the world's smartest company 4 years ago, and we have been in the top 3 every year since. So let's talk a little bit about what's going on in genomics. If you think about how fast this is moving, the first human genome took about 13 years to sequence and about $3 billion. And that was just in 2003. Since then, it was following kind of a Moore's Law curve until Illumina launched the GA platform, Genome Analyzer, in 2007. And we disrupted Moore's Law. We launched our HiSeq platform in 2010, and in 2014, we launched our X10 platform, which brought the cost of sequencing a human genome to $1,000. Since then, we've sequenced more genomes in that couple-year period than had ever been done before, and it's just moving very fast. And we're not done. In fact, we just launched our newest platform, and I'm going to tell you a little bit more about that. And for us, bringing the cost of sequencing down is essential for this to become pervasive and really a standard of care. And so we're very inspired to do that because we think that this is a way towards personalized medicine that's going to make a difference. And so just in the time that I graduated from UCLA in 2005 to now, it's been really revolutionary. I want to tell just a personal story about the fact that, this is having impact. There's a lot of work to do, but we're starting to see really the potential of this technology. And I want to tell the story of Marin Mejia. And she, right here in San Diego, actually, or just a few hours south of here, she was a 39-year-old mother, which is considered a high-risk pregnancy, and was given our non-invasive prenatal test. And if you haven't been following what's going on in the world of prenatal testing, it used to be that to find out if the baby you were carrying had a genetic disorder, you would get an amniocentesis, which involved a big needle being stuck into the amniotic fluid, risk for the mother, risk for the baby. And now, through the discovery that actually DNA of the baby is present in the mother's bloodstream at about 10 weeks of pregnancy. Baby's growing fast, shedding off cells. And if you can take a look at that DNA in a simple blood test, you can see if the baby has the potential for genetic disorder. In fact, more accurately than before. And so Marin was given this test, and it was shown that her baby had genetic abnormalities. The response to that is then to do further testing, usually imaging tests. And as they were able to do imaging tests, they found that actually the baby was healthy, and there must be something else going on. It was through this that they actually learned that the free-floating DNA in her bloodstream was cancer DNA. She had cancer that had actually spread at that point to her lungs and to her lymph nodes, and they were able to essentially kind of track the baby's development. At 32 weeks, they were able to deliver the baby by C-section and immediately start targeted cancer therapy for Marin. Now she has a healthy baby. She's still battling her cancer, but her tumors have shrunk and her prognosis is pretty good. But this is part of the effort that really led researchers to discover that cancer DNA is floating in your bloodstream, and if you can stage shift cancer and actually find it much earlier, especially cancers that are kind of deep in your organs and don't present until they're a massive tumor, and by then it's stage 4 and they've spread, and your prognosis isn't very good often. So if you can stage shift cancer and find it before it becomes a tumorous mass, and you have the potential to treat people in a much less invasive way, that really is what led to our investment into a company called Grail, as in the Holy Grail. Can you do a yearly screening test that would show whether you had very early stage cancer? And that idea has so much merit that it's gotten investors such as Bill Gates and Jeff Bezos, and we just actually had a round of funding. We spun it off as a separate company. And in this round of funding, we were able to raise $1 billion, or north of 900 million. So it is a big idea, and really could unlock the solution to cancer long term. Let me tell you a little bit more about your DNA, in case you haven't been as close to this as I have. I'm going to run the video and then tell you what you saw and maybe run it again because it goes kind of fast. Okay, so what you're looking at is kind of zooming into your body, zooming into your bloodstream, past some blood cells and finding one of your cells. in your cell, as you probably know, in the nucleus of your cell, you have your chromosomes, 46 chromosomes, 23 from each of your parents. And that chromosome material, kind of that X shape, if you take one arm of it, it's about a molecule of DNA. If you stretch that out, and DNA is packed in there with a number of proteins and other material, biological material, but if you stretch it out, you see that DNA is actually, that helical structure is made of 4 basic nucleotides, A, C, T, and G, and they pair up kind of on the other strand with their complement. And so sequencing DNA means actually knowing that code that is specific to you. If you did that for all your chromosomes and you stretched it all out, it's about 3 billion base pairs of nucleotides, and that's essentially what we sequence. That is your human genome. That is the blueprint of you, and yours is unique from anyone else's. So understanding that specifically is really powerful, and we think is going to be essential to personalized healthcare. If you think about what understanding your DNA can do for you, we talked a little bit about the application to reproductive health. And it's not just the non-invasive prenatal testing. It's also, you have couples who carry a rare genetic disorder such as cystic fibrosis. And the potential for them to have, if they're both carriers, of having a child with that disease is can be very high. And being able to do pre-implant genetic screening can assure a couple that they can have a child who is healthy and wouldn't have such a disease. The application to oncology, we talked a little bit about screening for cancer, but also cancer is a disease of the genome. You end up with a highly mutilated genome profile in that cell, which then replicates very quickly. And one person's breast cancer may be different than another person's, and that's true of, not only is that true in terms of targeted therapy, but also as you treat the cancer, it could continue to mutate, and so the drug therapy that you might have started with may need to change for it to be effective. So oncology is a huge area that we think has potential for this technology. Population sequencing. So populations, nations, want to know what are the genetic variants that are specific to their people so that they can administer better health care. And there are a number of countries that are taking on initiatives to basically screen their entire population and understand this. One country that's really been a leader here is the UK. And that was spearheaded by David Cameron, who is the former Prime Minister, because he happened to have a child with a rare genetic disorder who, unfortunately, at the age of 7, after having seizures like every day of his life, succumbed to the disease. And it was that pain that he and his wife experienced through not knowing what was going on, and then eventually not having the right therapy for their child that really made him inspired to invest in sequencing. And they're doing 100,000 genomes of the UK population with a focus on rare genetic disorder and oncology. We have a number of other countries that are starting these initiatives. China has a precision health initiative, the US as well, and we expect that this will lead to large-scale sequencing, so we can really understand what is that kind of phenotypic-genotypic relationship. There are areas of infectious disease. In fact, the Ebola genome, or the Ebola genetics, was understood by sequencing on our MySeq platform. Consumer, many of you have done the Ancestry or 23andMe test. And we think that that is a way for consumers to start to engage with their genetic profile, and we'll get them to transfer that to understanding their genetic health situation. And areas of like agriculture and of course forensics, which is one that probably is very well known. So if you can imagine a future of personalized medicine, and I do realize that a lot more has to be understood to truly personalize, and back to, we need to sequence a lot more people. We need to turn that informatically into useful information. But guiding selection of drug choices based on your genetics or based on the genetics of the disease that you have, knowing your predispositions, being able to give families a choice to be able to have healthy children if they have predispositions, helping to inform, whether you need to be vigilant about how much you monitor should you have the potential for or higher potential for breast cancer. You might want to get screened much more often, and a number of other applications that I'll talk about. So Lumina's mission really is to improve human health by unlocking the power of the genome. And we believe that we're very, very early in what is yet to come, but we're very confident that this is going to be a bright future for all of us. And we're inspired by the fact that we're starting to see more and more examples. I talked about a few of them already. Just want to talk about the case of this little boy here, Massimo Damiani, who was a child who was born, actually seemed very healthy at birth. By the time he was near 2 years old, he was starting to present with a genetic disease. And in fact, it got to the point where by the time he was 2, he had trouble walking, he was having seizures, he had trouble swallowing, and really looked like the prognosis for Massimo was very bad. And it was through his father being very determined and reaching out to a researcher who was actually, really in the kind of bioinformatics side, and through that researcher getting access to sequencing. Massimo was sequenced as well as both his parents, and from that they were able to see what genes were mutated. They were able to actually find drugs that were already screened to be healthy for human use and FDA approved. And Massimo was treated. This is him now as about 6 or 7 year old boy who is healthy. So there are cases of this. Unfortunately, sometimes by doing genetic sequencing, you're just giving a family an answer so they know what's going on and there isn't a therapy. But there are also cases where, a therapy does exist. It just, because these diseases can be so specific, they're, small population, it's a matter of kind of pairing a drug that exists with, with the genes that are affected. And in fact, our friends at Rady Children's Hospital in San Diego, they are pioneers in the field of doing this with Dr. Stephen Kingsmore. They're actually doing whole genome sequencing testing in a pediatric hospital setting, and they do the newborn baby and the parents, and are able to turn around a diagnosis of a rare genetic disorder in 26 hours. In fact, they just got the Guinness World Record for turning it around in essentially a day. And if you think about this, when of the babies that are admitted into the NICU, about a third of them have some genetic disease. And often these babies go from one test to another, maybe over a number of years, without understanding exactly what's going on. And not only is that a huge burden on the family, if you can only imagine, hugely impactful to the child, but also a huge burden on the healthcare system and the cost of the healthcare system. So if the cost of sequencing and all the informatics around it can be turned around in 26 hours, just imagine how effective that is in terms of value for the healthcare system, and how many people you impact by giving them an answer, and often, or more often now, giving them a solution for their child's disease. But we didn't stop at the $1,000 genome. In fact, we just launched our newest high-throughput platform, which is called the Novaseek. And I'm happy to say we just shipped the first units to customers. They were just tweeting out that they received them at the Broad Institute and at WashU and a few others. This is the platform that will allow us to sequence a human for $100. So at $100, and it's not going to happen immediately. This is a platform that over a number of years will allow us to get to $100. But at $100, you can see how this can become standard of care. And you can also see how a lot more sequencing is going to be done, and populations will be sequenced, and we'll have lots of researchers and physicians coming together to really understand kind of the genetics behind disease and how to treat them. I'm just going to run one more video here if I can. Tell you a little bit about what it takes to bring together one of our sequencing platforms. So kind of getting back into the technology side, this is incredibly complex technology. In fact, since that's where I come from, this is cutting edge in terms of everything engineering. It's cutting edge in terms of everything science, and it takes true collaboration and teamwork to bring it all together. We also have medical doctors. We have a huge range of people that come together to really not only make the technology behind our platforms, but actually make it applicable to health. So here's a story behind our Novaseek. So we need innovators, I think, to make the change that we all want to see in our healthcare. And I will show one more slide here that shows everybody, all the fields that come together. We have everything from rocket scientists to medicinal chemists to bioinformaticians. This is complex stuff, much more complex than anything in the consumer electronics or high-tech space. And I'm glad I'm here at a fantastic university where we're educating lots of people across all these areas that are going to drive the future. We're a global organization. We have actually 20 sites, but we're highly rooted in California. And in case I haven't stated it specifically, San Diego, Southern California, really is the center of genomics in the entire world. And with Illumina's presence there, but also our collaborators, we have HLI there. We have a number of universities that are also connected with us. It is an ecosystem for life sciences in San Diego, and now also broadly in California, and I hope that we can do a lot more with UCLA. We started as a startup, and now that we're $2.4 billion, I guess we've graduated. In fact, we just got the Small Business Association Hall of Fame Award, so I guess that means we are graduated. But we're highly supportive of the startup community because we know that it's going to take an ecosystem around this really to make this technology applicable to all the areas that it can go. And we have an accelerator program. This is in the Bay Area. And we provide, we hand select the startups kind of based on their potential, but we provide capital, free access to sequencing, coaching. They can set up in our facility. We give them lab space. We give them RAs. And we've had a number of successful companies then kind of graduate and spin off into their own companies. So we do believe that the startup world is going to be a huge part of how we take this forward. And I had a former colleague and alum talking about a potential gene therapy startup. This would be the perfect place to look if you're interested in getting support. I'm going to leave you with a quote from our CEO and a video that kind of brings this all together and talks about how we see the future. And I hope that I can inspire many of you to get involved. If you're a student looking for a career in this area, would love to hear from you. And if you're in other areas of healthcare, we would love to collaborate because it's going to take a village to make this happen. So there's a dramatic DNA revolution happening today, and Illumina is leading it. Our technology and the solutions we continue to bring to market are transforming our understanding of the genome and will ultimately transform healthcare. So that's from our CEO, Francis D'Souza. I should mention that greater than 90% of sequencing information that's used in any kind of major peer-reviewed publication or journal comes off our platforms. So we really are kind of leaders in the sequencing space. And here's the video.
I remember the first time we were able to sequence a whole human genome in a single day. You can suddenly see what could be possible.
When I first found out that she had cancer, I felt like I was drowning. I wish that it was me, not her.
There were many sleepless nights. It was technology that each piece of it was cutting edge. We knew that we were going to make a difference for our children and the world.
15 years ago, seeing my kids grow up wasn't a reality. They found a perfect match the same day. And to think that I'm carrying somebody else's heart and that I'm not only responsible for my own legacy, but theirs as well.
I thought it was never going to be possible. Every kick reminds me that it's real. You can feel this being inside of you, and so excited to meet her for the first time.
I never dreamt that in my lifetime that we would have the answers where they will know the individual who's at risk of heart disease and all sorts of chronic illnesses because of this tool that was in my hands.
We used to race against the clock. But now we catch it early and save communities.
I remember not being able to do what all the other kids could do. And it was just hard to breathe. My dad said my uncle died from it when he was 10. But I feel lucky. I feel like I can fly.
When I I saw that first crop, it was unimaginable how many farmers we could help, even in the most devastating and challenging climates. And it's just the beginning to a world that had an adequate food supply.
It was like coming up for air when I remember how different cancer treatment is today. That makes me cry. You can give life to somebody that has so much to offer. And when you can see that, you feel joy in your heart.
The DNA molecule is the software program of life. We certainly couldn't have predicted the breakthroughs, the ways that can positively impact human health. I can't imagine anything more powerful than that.
Great. Thank you so much for your time. And I don't know if we're going to take questions.
Yeah, that was a great talk. There's no doubt that genomics and sequencing is the future when it comes to cancer, reproductive health, plant biology. There's absolutely no doubt. But as of right now, my question is, what are the major pushbacks that you're facing? Because you're a global company, you have offices in China and England. So what are the major pushbacks that you face from maybe payers or governments or even providers? What is their reluctance when it comes to adopting this at a larger scale? Is it cost? Is it proof of concept, efficacy? So what is it?
Well, I mean, there are a lot of the barriers that you just talked about, and actually the panelists, the first panel that was up here spoke to this a bit too. There is, always the view of, are you opening up a can of worms that we don't have kind of answers to? But increasingly, I think, one, the cost of sequencing had to come down for it to even become a possibility. And as that's happening, and as the clinical evidence of this actually being effective is emerging, and a number of examples that I gave show that the clinical utility is there. Certainly, I think, rare genetic disorders is where the clinical utility is probably, furthest along, and one that we believe, and I gave the example of Rady's Children's Hospital. I think that one is going to take off faster. NIPT now is kind of a standard of care in many medical systems. So when there is just a propensity, overwhelming amount of data showing that this is better than the current test that we're running, I think there will be a tipping point. And in many cases, it's coming from consumers becoming aware and demanding it. So. But yes, there are a number of barriers, and if you're in the business of helping to remove those barriers, we'd love to talk to you too. Yes.
Thank you so much. As someone who's used Illumina technology, I can say that it is as amazing as you presented it today. My question is that while we know that the blueprint, as you described it, is important, the science also indicates that's often only part of the equation with things like gene-gene interaction, epigenetics, protein-gene interactions, environment. So with this knowledge and as the science moves forward, how does Illumina take this understanding and incorporate it into its businesses? Is it through data? Is it through new technologies? How does Illumina think about this?
Yeah, I think, there is a lot to be understood. There's the epigenome, the vast amount of information that's going to come from the ability to sequence at a cost structure that makes it available, I think is astounding, and it's also a huge opportunity, which is why we feel that eventually this is going to be, in my opinion, it's going to be a business that's really hard for us to measure right now in terms of scale that it can get to. We've heard 20 billion, we've heard 50 billion, I've seen closer to $1 trillion. There is, and that is why I think that, you know, it's going to spawn a huge ecosystem of startups and other companies and partners. For Illumina to be successful in really getting to the next stage, I feel that, you know, our view of partnership with all these companies and really encouraging innovation across our industry is going to be super important. And I'm pleased to see that many academic institutions already have sequencing in their chemistry programs or biology programs, kind of across, starting to show up across the university. If they have a medical center, you know, often they have sequencers there. So it is going to take a lot of familiarity and a lot of innovation to come. So this is not a world of just physicians. Physicians are incredibly important, and my father is a physician, and so I have deep respect for them. But you know, there's got to be technologists, informaticians, business-minded people who can really, you know, bring this all together.
A really inspiring speech. You brought up a really good point in the previous panel. A point was brought up that there's a wealth of information out there generated through sequencing, but the clinicians, their action items are limited in terms of what to do with this wealth of information. So as someone from the sequencing industry myself, could you give some insights into what we are trying to do to bridge this gap in terms of information to clinically actionable items, in terms of FDA being a huge roadblock, if that's the right word? I'm sorry.
Well, then I think Donald Trump said he was going to streamline the FDA. I don't know if that's happened just yet. I think that relevant to getting this to the place where it can actually make an impact in the clinic, I think is your basic question. A lot does have to happen, and the onus, I think, initially is on us to actually to make the cost structure possible, to show the clinical utility, and then I think once clinical utility becomes clear and you really can't question it, and as I mentioned, consumers, patients are actually asking for it. It is going to take some of that. It's going to take physicians who are coming through more recently, graduating with not finding this to be scary, actually having this level of information. We're going to need a lot more genetic counselors, and actually I think UCLA has a great program for genetic counseling, but that's an area that is really underserved for this to happen. And in terms of at least our own interactions with the FDA, they are wanting to, and I'm sure you find the same. They're wanting to collaborate with us and find a, they're great people who want to protect citizens from medical devices that could cause harm or cause more question than solution. But they want to work with us to actually put us down a path so that we can get our products regulated. And so I feel like we're there. We're kind of at the tipping point where this is going to come together, and we're going to see much more presence in the clinic of sequencing and genetic information. Thank you very much.